If somebody's absent, they're watching the video, they're like, wait, why isn't Farkas talking? I don't know, I just figured I'd start writing and see if you caught up. All right, lesson 1.4, arithmetic sequences and lines. Arithmetic sequences and lines. Now, when we did our lesson 1.2, our explicit formula lesson, and we looked at both arithmetic and geometric, right? We talked about the arithmetic had this linear relationship that seemed to be going on there, and then the geometric had this exponential-ish, curvy relationship. Okay, and as we extend through our class and we begin to talk about these different types of relationships, we're going to come back to the exponential relationship in the geometric sequence. But for the remainder of our time with this, as we did with our summation, we're going to now focus our efforts towards arithmetic sequences and this idea of how does that relate to this kind of straight line-ish relationship that we observed the other day. Okay, so we're going to start a little bit easier, and then we're going to expand our thinking a little bit and push our brains. So let's start with this. So we are going to consider the arithmetic sequence. There's information in there, right? Now you know what kind of a sequence we have. We're going to consider the arithmetic sequence that looks like this. Okay, well, we already know it's arithmetic. We were just told that, right? Okay. And if I don't specify for you specific term numbers above it, right, if I just give you this sequence, then the assumption is you understand that 8 is the first term in the sequence, 11 is the second term in the sequence. They're separated by commas, right? This little ellipse thing would mean that there are more numbers to come or something larger than the next term in separation. And so now we know that these terms flow consecutively in the sequence. Okay, so then we can determine, since it's arithmetic, what our common difference is, which is what? 3. Okay, good. All right, so we know that. Okay. Now, we're going to consider an alternate look. Okay, an alternate look. And you know what? Let me just take a second, and I'm going to give you guys some straight edges so you can draw some nice straight lines. What I want you to do, I want you to skip 2 lines of space here. I want you to skip 2 lines of space, and then actually 3 lines of space. You just skip down 1, 2, 3 spaces, and you're going to start by kind of like out here lined up with the A. Let's just draw a straight line, I don't know, about yay-ish long. Yay. Yay, exactly, yay-ish. Okay. And then what we're going to do is I'm going to draw a line here at the end. And then I'm going to go here, and then here, and then here, and then here.
Yeah, I'm doing it in centimeters. What's your guess number?
Yeah, my yayish is probably a little on the long side. I'm gonna shorten my yayish a little bit, maybe like more like that. You could just erase off the end there. Need too much more there. Okay. So here's what I'm gonna do. And then out here on the margin area, I'd like you to write term number and then sequence value. Out here on the margin. We're gonna leave this space area here. So leave a little space right here, okay? All right, so let's fill in some things that we know, okay? So we know the first term has a sequence value of 8. And the second term has a sequence value of 11. And the third term has a sequence value of 14. And the fourth term has a sequence value of 17, right? And so on and so forth. Okay, we good? All right, now, from this line right here, you're going to come over a little bit here on your paper, and you're going to drop down 2 more lines. And then you're going to do a nice long line down here. I know, all these being specific, but your notes will look nice and neat.
I know.
And then you're going to draw another line meeting that line like that.
What the heck? Oh my gosh.
And then you're going to go like this. And you're going to go like this. And then you want about the same amount of space that you have here, you want going that way. So then you'll go 1, 2, 3, 4. Doesn't have to be perfect, just close. And then we'll go 1, 2, 3, 4. All right, you got it? Okay. I would like you to draw the discrete picture of the sequence in the table. I would like you to draw the discrete picture of the sequence in the table. Yes, discrete. We talked about that last class period. Actually, we talked about that in the 1.2 class period. I'll tell you what, I'll give you the opposite of it, okay? That would be the non-continuous picture. No, I don't want the continuous picture. I want the discrete picture of the sequence. I'm sorry, continuous would be the opposite. Yeah, I think I said that wrong. Yeah, continuous would be the opposite. So I want the non-continuous picture, which would be the discrete picture. And why don't you go ahead and write in the term number and sequence value, like kind of like in, you know, like in a parenthesis, sort of like one number, comma, like a what? Oh, wow. Now you're getting way advanced. Hang on. Let's not go too far here.
Yeah, my bad.
Okay.
We kind of use ourselves. We kind of know our spreadsheets.
What?
Yeah.
Here's what you should have put on your picture.
Nice.
Discrete means that it's non-continuous. So it is these items and only these items. Now that's going to come important as we continue along with our study in Algebra 2 is the difference between discrete pictures and continuous pictures. Okay? Because what shape or what relational pattern do we notice about this? We already know this, right? What is this?
Linear.
It's linear, right? We've already seen that relationship, right? So if we wanted to draw the continuous pattern of this, then we would just connect these points like that. Now it includes everything like the 1 1/4 term or the 1 7/8-ish term, even though there really isn't such a thing. Or is there? If we draw it continuously, then there should be. But that sounds weird, right? The 1 7/8-ish term, like that just seems very strange for us to understand. But if we're following a pattern and we're going from one full sequence term to another full sequence term and it's +3, couldn't we go from one full sequence term to a 7/8-ish version of that? Wouldn't it be just 7/8-ish of 3? That would get us in the same area, right? And that would actually fit on that relationship. Okay, so discrete versus continuous. Okay, all right. So this is like a line segment though, right? This is not a line itself, but it's a line segment. But I mean, we could take the sequence out forever and ever and ever and ever, right? So we could actually, if we wanted to, we could take this and extend this infinitely that way, yeah? 5th term, 6th term, 7th term, 8th and a half term. If we wanted to. We go like 1.5 up. What are you guys doing? You're going to break my rulers. Don't. Yeah, don't just.
Yeah, it's not a sword, guys.
Put it down. Yeah. See, Jack. See, this is what happens. You know, this is what happens. You know, just for drawing lines, not for steering the car. You know. Okay. Could I extend my linear relationship the other direction? I could, right? I mean, you know, like if this is this continuous linear relationship, right? We could extend that the other direction. I'm just going to draw this down here, like this, right? All right. Okay. So if I do that, first term, second term, third term, fourth term, is it possible to have a zeroth term for this? Okay. All right. What would our zeroth term be? 0, comma what? How'd you figure that out?
Because it intersects at the y-axis.
Well, you can really, 5's kind of hard to see there on that graph. Is there a better way to know that? Yeah, -3 from what? No, the common difference is +3.
Yeah.
But the common difference is at -3. So we're just backing it off so that we know that if we started at 5 and we added 3, we'd get 2/8. Okay, all right. But in our mind, we subtract it, right? Okay, all right, good. Okay, so then that makes this 5. All right, good. We could put a point right there, right? Okay, all right, good. Good. Okay, let's do this then. Let's come back over here to our little table, and now let's extend our line out a little bit more back this way into that space I told you about. Because now we can add the 0th term at 5, right? Even though we don't really have a 0th term in our sequence, we can say that we do if we're extending our continuous version of this graph. Yeah, everybody good so far? Okay. Okay, so this over here, what were we tracking over here? What do these numbers represent? Okay, let's write that down. So this is the term number. And what are we tracking over here?
Value. Sequence
The
value.
sequence value. Okay, sequence value. Luigi, you said something about a couple of letters that usually associate with things that run left and right and things that run up and down.
Yes.
Okay, so like this kind of looks like an x-axis and a y-axis, right? Since we've got two perpendicular number lines meeting, right? So what if we said, would it be reasonable for me to say, okay, well now we have a table of values of x's and y's and inputs and outputs.
Oh, yeah.
What do those associate
A
with?
function.
Inputs. Oh, what kind of a function?
Linear function.
A linear function. Okay, all right. Now we're talking some algebra, right? Okay. So how do you know this is a linear function? How do you know it's a function? What is a function? Can anybody tell me what a function is?
You put something in and then you get something out. Is that what a function is?
In terms of Excel, yes.
Okay, question.
Yeah, I forgot actually which color.
Okay, question. I put something in and I get something out.
Sounds like a form. I think we should have like an Excel class. In our final, it's like.
So if I put in, what am I going to get out? Okay. If I put in, what am I going to get out?
Yeah, we can say it with Cornell.
Because
Because you have one, you get one exit to start.
And is that it? Okay, we'll come back to that question. That's a good question for another time because that doesn't really relate to today too much, but we'll come back to that. Okay, hey, let's talk about something else. So you guys told me the common difference was 3, right? Like we were doing this notation before, right?
Yes.
Okay, so the sequence value was going up by 3. What was happening to the term number at the same time?
Increasing.
So this was increasing by 1. Would it be reasonable for me to say that. For every 6 amounts I increase the sequence value, I just need to increase the term number twice as much.
Yes.
That's reasonable? Why is that reasonable?
Just 260.
Whoa, wait, whoa, you got fraction. Where are you getting fractions from? I don't even have fractions on the screen. Are you comparing numbers in fractions?
Well, yeah, because like if you move the top one 1 and the bottom one 3, then 1 over 3, and then that's the
What is that called when we compare values in a fraction? Ratio, right? Okay, we're comparing ratios. Actually, the ratio that we're comparing here, if you want to get kind of specific about it, has to do with this right here, right? And the ratio that we're comparing here that we were just talking about looks like this.
Wait, why'd you try triangles?
That's a great question.
Oh, doesn't that do like Let me tell you that.
Does anybody know why I drew a triangle there? It is a delta. It is a delta. What does the delta do for us? Okay, all right, so delta D difference, right? Okay, good. It's the change in some Y values and the change in some X values. So, like, for example, if we wanted to know, okay, so what Nadia was saying was we could do whatever we wanted as long as we do it equally the same in the top and the bottom, right? So, like, for example, let's say, what would be the change from 17 to 5? Okay, well, we could say, we could start with 17 and we could take away 5. And that would give us what? Okay. So if we went from the sequence value 17 to the sequence value 5, what would we have to do in terms of term numbers? We'd have to go from 4 to what?
0.
Okay, all right. So then from 4 to 0, which is 4. And what's that simplified to?
So you divide both by 4.
3.
You get 3 over 1. Which is really just 3.
Or is it?
No.
That's the common difference.
Is that the slope?
Oh.
Wait, what am I doing?
Finding the slope. A squared
The slope. Yeah. I'm finding the slope. Huh.
Head drop.
Wait, I also found the common difference. So wait, the common difference is the same thing as the slope? Okay.
Just another day.
Okay, just another day, right? Okay, all right. How about we write the explicit formula for the sequence above, starting with the formula we use starts with the first term, right? So how about we do right here, right below this, let's write the explicit formula for the sequence above. What's that? Okay.
It's not mine.
One thing I can tell you for sure is it's not mine. Because it would be really, really little, especially since I cut it this morning. So,
0 plus 3.
Okay, all right, you're writing the explicit formula. Ready to go.
No, we have it.
Okay. You should have. Yeah? Everybody good? Okay, question. What is this? Common difference. That got distributed here, right? So then this is still the common difference? Is that still the common difference? Okay, let's do a little divider right here. Okay, so this is our explicit formula. Okay. So let's just do a little labeling so we're clear. This right here is our simplified D. Right, that's our common difference in its most simplified form. Because again, we talked about how we could value that common difference in the term numbers, right, in different ways. And so that's our simplified D. In terms of our sequence, What is this? No. In terms of our sequence.
Yeah.
Okay, so this is the 0th term. I like that. I'm going to put what you said there, a sub 0, right? Okay, that's the 0th term is what we're talking about. Okay. Well, hopefully you're starting to piece this together. Shocking, huh?
Yeah, that is the slope formula.
Okay, so then... Oh, no, you didn't just freeze on me, did you? Okay. So what is this? Okay, so this is our slope, right?
Yeah.
Okay.
This is like this would Bill.
And what is this?
Which one? D?
That's our... Okay, that's our y-intercept. Okay, so now we're seeing that these are two of the same thing. So our explicit formula, or we can put here, because sometimes I use this too, explicit rule, is the same thing as our slope-intercept form, which is what we would call the equation of the line. Or for that matter, the equation of the function, right? And these two things are the same. Okay, so the connection between now the explicit rule, arithmetic sequence, line, algebra 1, y equals mx plus b, slope formula, it's all the same thing that we're talking about. We're just seeing how this different language comes together here, okay? All right, now, there are ways you've learned to do things in Algebra 1, but I'm going to kind of push your thinking a little bit in terms of how we can come up with other pieces of information by using our sequences, all right? Everybody's good here? We cool? All right, let's go to the back side of our paper, okay?
Dude, stop yapping.
Jack, I actually know you're not talking.
He's like,
Yeah,
I'm
I
just
literally
letting
never
everyone
read something
words.
possible with Jack. And that's coming from me.
Okay, ready?
Don't put me under an umbrella with that name. Are you actually? She said we're the three most chatty people. Like I think that offensive. I put myself in that umbrella too.
Oh, okay. You see what's happening?
Yeah, I do actually, because we are.
Wait, I gotta see what's happening here.
You're not up there. You're so you are not up there.
Oh, we're in front. Yeah, you guys come on. You guys negative second here. Was that
Yeah, is that even possible? Well, if we have a continuous line, it's possible, right? I mean, that's how we got our 0th term, right? And our 5 7/8 term number, right? So with a continuous line, it's possible. Okay, so we're going to leave this middle one for now. I'm not going to tell you what term number that is, but let's do this. Let's set up a table like we did previously. Let's skip down. I want you to skip down like 3 lines of spaces, actually 4 lines of spaces here, so that you have a little room to kind of write some things in here. So I'll go 1, 2, 3, 4 lines down, and then I'm going to do a little table like this. And we know that this is an X, Y term number.
Sequence value.
Right. Sequence value. Okay, and I'm just gonna make these as we know them. So like the negative second term is negative 7. The term is negative 3. The fourth term is positive 5. The seventh term is positive 11. Now we don't have consecutive terms. We have just a random selection from our sequence. The question is can we come up with an explicit formula for this particular thing, especially since we don't have the first term?
Let's find the, what is this, common difference? Yes.
Okay, so again, our explicit formula, right, is our a sub n is equal to d sub n plus some 0th term. That's in its simplified form. Our d sub n, right? But we got to find the simplified d sub n. So let's talk about some things that we could compare. Like, let's do this one. What can you tell me about the change in sequence value there?
6.
Plus, minus?
Plus 7.
Okay, so this was plus 6. All right. And what can you tell me about the change in term number?
3.
Okay, plus 3. Okay, so then we could say the change in the y over the change in the x for this one is 6 over 3, which is 2 over 1. And just to be clear, right? I mean, we could have done that. We could have done that like 11 minus 5 over 7 minus 4, right? We could have started here and gone this way and here and gone this way. Or we could have gone 5 minus 11 and 4 minus, or could we do that both ways? Does that work both ways? Potentially?
Yeah.
Why does it work both ways?
Because the y.
Hang on.
Like the second way, you would do if you get two negatives, you have to.
Okay, so negative divided by negative still becomes a positive, right? So it's still a positive variation of that line. Okay, all right. Let's try another one. Let's go all the way from the 11 and let's go down to the negative 7. What's the change if I started at the 11 and I went all the way down to the negative 7? Write down what you think the change is. Why don't you write it down right down here? What do you think the change is? You started at 11. Think about a number line. You started at positive 11, and then you went all the way down to negative 7. What would you write? You should write minus 18, right? 11 steps back to 0, and then 7 more. And we went to the left, so that was minus. All right, so then we would have to go from 7 to what down here? We'd have to go to the negative second term, right? What's the change there?
9.
Negative 9. Okay, so then what we're saying in this example is that the change is negative 18 over negative 9. How's that work out?
No. It's still 2 over 1.
Still 2 over 1. Okay, now, I told you to consider the arithmetic sequence, right? What if I just said consider the sequence? Could you prove that it is in fact arithmetic since you don't have consecutive terms? You could, because the ratio of change is the same. You see that? And if the ratio of change is the same, then it must be an arithmetic sequence. So I really could have just said to you, consider the sequence, and the first question would prove that it was arithmetic, right? And again, we could do the same thing over here. In fact, let's just jot it down just so that we have it on our notes. So we could have gone negative 7 minus 11, right? That's one way we could have gone it. And then that would have been negative 2 minus 7. Or we could have gone 11 minus negative 7, which turns into a positive, right? And 7 minus negative 2. Same thing. Okay, so now we know what our simplified D is for this particular problem, right? Okay, so that's good. We know what our simplified D is. Okay, so let's do this. Okay, number 1, our simplified D we know comes from some subtraction problem of the y's, right? Like if we take some sequence value and its partner term value minus another sequence value and its term value, literally the slope formula. So in this problem, that's 2. So the ratio of change between sequence value and term number is the same thing as the ratio of change between y and x, which is our slope of our line. Okay, good. All right. Now we got to find the 0th term. Do you remember how to do this in Algebra 1? How would you have done? You're looking for b. No, don't do it that way. I don't want you to do it that way. I want you to do it a different way. But that's what we're looking for, right? Like, what would you do if you had to find b? The first thing you have to do is find the slope, right? So that you have y equals 2x plus b. Then what would you do? What do you do in Algebra 1 when you have to find the slope of a line and you have y equals 2x plus b? You have to find the equation of the line. You'd pick points, right? You'd plug them in and then you'd solve for b and then go back and right. Okay, well, let's think about this a different way. Okay, let's think about this a different way. All right, you ready? So we know that the change in y over the change in x is 2 over 1, right? We know that's the ratio. Right? The change in y over the change in x is 2 over y. Okay. So I could pick any place to start. Okay, I could pick any place to start and do my change in y and my change in x. And so, like, let's say I started with the 7th term. Okay? How many steps backwards would I have to take from the 7th term to get the 0th term? I'd have to take 7 steps back, right? Okay, so let me change this down here to 7 steps back. So I'm starting with the 7th term and I'm taking 7 steps back to get to the 0th term. Okay? Well, now I can use a little cross multiplication to solve this proportion, right? Because I got 3 things that I know. So what I could say is that if I took 7 steps backwards in my x, then what would I have to take backwards in my y? No. I'd have to take 14 steps backwards in my y, cross multiply. Change of y is equal to negative 14. All right, so then if we were talking about the 7th term, I went 7 steps backwards to find my 0th term. That means I have to start here, and I have to take 14 steps backwards. So if I start at 11 and I take 14 steps backwards, where am I going to end?
You're going to end at negative 3, right?
If I start at 11 and I go 14 steps this way, 11 back to 0, and then 1, 2, 3 more. So I'm going to end up at negative 3.
Thank you.
What term number is this?
Yo.
That's the 0th term.
Huge play by Jack.
I think that was Mr. Farkas's play. Hello.
Yeah.
I set that one up. That was me pitching over the plate. You just hit the ball. That's all.
No, he just stuck his bat out.
Yeah, exactly. Yeah, you bunted. Yeah, that was a bunt. Okay, let's see if that works anywhere. Okay, let's see if that works anywhere. How about okay, you guys pick one. Josh, you pick one. So where do you which one of these terms here? Here, we already did this one. Which one of these terms do you want to start at? Do you want to start at this one or this one? The negative 2 or the 4? You want to start at the 4? Okay. All right. So if we're going to start at the 4, so then let's redo this problem. So we know that change in y is the same thing as, okay, so from the 4th term to the 0th term is how many steps? 4. So we're going to go down 4 because it's positive 4, right? And we know that that ratio is the same as 2 over 1, right? So then from the 4th term down, how many steps would we have to take in our change in y? We'd have to take 8 steps down, right? Okay, so let's start at +5 and take 8 steps down. Where do you end up at? -3 again, right? So we're determining our B value instead of just solving the equation, plugging in points. Now we're finding it in terms of using our rate of change, right? And so in this case, our 0th term, right? This was 11 in the y value minus 14 gave us -3. And this one was 5 in the y value minus 8 also gave us -3. And so now we found our 0th term. And when we have our D and our 0th term, either one of them, then we can write our explicit formula by just going A sub n is equal to D and 0th term. And if I just gave you that explicit formula, you could go, well, if I start at -3, the 0, comma, -3, y-intercept, then I could do a rate of change of +2/1. The change in y, up 2 on my sequence value, 1 term over, up 2 on my sequence value, 1 term over, up 2 on my sequence value. I should probably do it this way for you guys since you're looking at me, right? Okay. Make sense? See the connection between arithmetic sequences and lines. Explicit formula and the slope-intercept form of a line. Good? Good. Then you got it. And that is it. Let me give you some homework.
Yo, you guys think mouse train